present here. So, as Parain had introduced, I am Ajay. I handle the operations of Promethean Energy. So, in this session, I'll be mainly talking about all the solutions what we have implemented across India in order to help industries meet their sustainability targets. So, before we get into what the solutions are, I'll just give you a brief introduction of who we are and what we do. So, our main aim is to help industries and factories to meet their sustainability goals. We help them achieve this through two divisions of ours. One is Promethean Energy, which helps with thermal solutions, and the other is called SensorMac, which helps with IoT solutions. So this presentation and this few minutes, I'll be talking only about Promethean Energy, and I won't be getting into IoT. So we have been working with multiple companies in India and almost helped these companies reduce about 100,000 tons of CO2 emissions only through thermal energy and heat recovery solutions. So we have worked across major industries in India and also have been recognized by all the central agencies in India. And we are a team of 30 engineers who have the mission to identify different sources of waste heat and other places where we can help an industry to become more sustainable. So all our solutions are designed based on heat pumps and heat recovery system. Why means when you look at the overall picture on how industries are heating or generating heat, most of the what you can say is that most of the energy is expensive. So when you have a heat pump or a heat recovery system, the cost of generating a kilowatt of energy is very low. For example, if you're using a diesel system to generate hot water, it would cost the end user about 10 rupees per kilowatt. So we design our solutions with heat pumps and heat recovery systems so that they can reduce this cost and help them with multiple other, they can save the operation cost basically for generating hot water. So the different solutions what we have are, we have designed a product called as CompMate, which is used to help industries to recover waste heat from air compressors. So air compressors is critical for any industry because they are the main source for creating automation and processors for machines. Without them, the industry can't run. But about 90% of the energy which is given into an air compressor is rejected as waste heat. So we help to recover this waste heat from this air compressor and use it to generate hot water. So this application we have installed in multiple sectors, and in the case of automotive industry, we have used it to preheat boiler water, use it to offset electrical heaters in component washing machines, and also used it in the paint shop in the process tanks. This particular installation has been compatible with all the air compressors we have in the industry. So we have installed it on Atlas Copco systems. We have installed it in Kaiser systems, in Ingersoll Rand systems, as well as Solar systems. Similar to this, we also have a solution known as a ChillerMate, which recovers waste heat from chillers. So chillers have a lot of waste heat during the refrigeration cycle. So the amount of heat in the refrigerant is actually released in the condenser. So we try to recover this heat energy and give it to the industry so that they can use it to generate hot water. So this particular application can be used wherever they have multiple chillers in their facility. Similarly, all the industries have a lot of hot gases, whether it is from a boiler, a furnace, a dryer, or an ashtray. All these gases have been dissipated into the atmosphere. So with the help of a flow therm, the industry can recover these waste hot gases and use it to again generate hot water in order to offset their existing hot water generators or boilers. This current installation, we have done it again in multiple automotive sectors. And again, the commonly used applications are for boiler preheating, component washing machines, and in the paint shops. Another one of the most commonly used applications these days are heat pumps. Because of the cost of fuel, a lot of industries are planning to cut down their hot water generators. So in case you want, so with high temperature heat pumps, you can actually generate hot water up to 90 degrees centigrade so that most of the hot water can be generated from it and used in the processors. Most of the processors have a hot water requirement between 50 to 60 degrees, which is easily available with the help of heat pumps. Again, an added advantage of heat pump is that it also has a cooling side, which can be used to offset the load on the chillers, thereby also giving a reduced load on the chiller and saving energy. Similarly, most of the industries, if they have oil-free air compressors, it also is a major source of waste heat. almost about 50% of the energy which is given into the air compressor, I would say even 100% of the energy given into the oil-free air compressor is being rejected into the atmosphere. So using the system, a minimum of 50% of input energy can be recovered and used again to heat water or any other process liquid in the facility. Apart from this, we also help industries build one-off solutions. For example, we have built a effluent heat recovery system because we identified one of a large textile industry in India wasting a lot of hot water, and then they were draining it into the ETP plant. So in order to help them recover the waste heat and reuse it, we customize and we design this solution so that the waste heat can be recovered and reutilized properly. So some of the case studies, what I would like to showcase in terms of automotive sector are, so we have seen a lot of, we talked about waste heat recovery from the air compressor. So this particular installation has been done in a large truck manufacturing plant in Chennai. So what happened is that the plant had multiple washing machines and each of them had electrical heating coils. So problem with that, one, electricity consumption is there. And second is that the coils would fail repeatedly, causing a maintenance issue for the team, as well as product quality was not up to the mark. So we audited the facility and found out that they had multiple air compressors with them. So we installed a couple of heat recovery systems and recovered the waste heat from the air compressors, and also designed the entire piping circuit as well as a heat delivery unit, so that all the recovered waste heat can be efficiently delivered to all the washing machines. So this heat delivery unit has been specially designed so that all the waste heat can be recovered properly and delivered efficiently. So with proper engineering, all the waste heat can be delivered to any location. And each and every heat delivery unit or any equipment is manufactured as per the requirements at site and as per the conditions at site. It's not standard equipment. Each and every device or equipment is manufactured as per the conditions at site. So these are some of the devices which are installed at different facilities across India. So over the years, we have been iterating the designs as per the inputs which we have received from multiple clients. And again, since we also have a digital wing with us, we actually utilize all the functionality we have. So what we do is that in order to closely monitor all our systems, we install IoT devices in all our equipments. And we try to get the data and understand what our equipment is going through and is it functioning as per the efficiency of the design what we have made. So this data and this dashboard is again shared to the client so that he can also have a better monitoring of what is happening in the facility on a shop floor. So this has been actually useful, and this is one of the main reasons why we had to start a separate digital wing in our company with IoT. An added advantage is that with this IoT system, all the data is available. So all the historical data is available for the client, so they can analyze how much of energy has been delivered, how much has been saved, how much are the electrical heaters working, is it functioning, or is it switched off, or is there any issue with our heat delivery system. All the data is available. Apart from this, we also send them reports like every week so that they can understand what is happening in their facility. Usually, when you look deep into a system, only you'll be able to identify is it functioning properly or not. So we ensure that we give them reports at the end of each shift or at the end of a month or end of a week as per their requirements, both through WhatsApp as well as email, so that they get to know what is happening and there is a complete transparency for them. Similarly, this is one of the major projects what we have done again in Chennai. So one of a large auto ancillary manufacturer, they were using hot water generators to actually maintain temperatures of the 4 process tanks in their paint shops. So about 65 lakhs per annum is spent only on fuel. So they were using fuel oil to heat as a fuel for the hot water generator, and they used to run it continuously. So again, what we did was we audited the plant, and again we found out multiple air compressors were there. So we installed heat recovery systems to recover the maximum heat what was available, and for the remaining of the heat what was required, we installed a couple of heat pumps. So with the help of heat pumps as well as heat recovery system, the entire company was able to cut down the working of the hot water generation, which resulted end of the day reducing the carbon footprint by 90%. So the hot water generator hardly runs every day. Maybe if it is when the plant is on a shutdown or anything, when they need a quick boost of hot water, at that time they might use it. Otherwise, most of the 95% of the time, only the heat recovery systems and the heat pumps are working. So this particular project really helped the company in reducing the carbon footprint by a lot. And also the cost of running, they used to spend 65 lakhs for the fuel oil, now hardly nothing. They are not spending much because of these heat recovery systems and heat pumps. And moreover, what happens is that 50% of the total heat again is being balanced by the air compressors. So only when there is a requirement of heat, the heat pumps work. Across all of the time, only the air compressor heater is being used by the paint shop. So these are a couple of solutions what we have installed across different plants, and all of them have helped the client in achieving his sustainability goals as well as reducing his carbon emissions.
Thank you so much,
Yes.
Mr. Thank
Yeah.
you so much, Mr. Ajay. That was very informative. We will now open for questions. If there are any questions, we will take them now for the next 5 minutes. While someone comes up with a question or has a question in mind, I, out of curiosity, wanted to understand, when we talk about waste heat recovery from air compressors, how much of this waste heat can actually be recovered for you?
For about 68% of the energy which is given into a compressor can be recovered. So let's say if 100 kilowatt of energy is being consumed every hour, about 65 units of heat energy is available for recovery. So this indirectly offsets any requirement what the client has.
Right. So this would majorly save on a lot of energy consumption.
Yes. So 65%, 60, we are giving the client 65 units per hour. So let's say the industry works for 10 hours. He gets 650 units freely from the air compressor.
Right, and that automatically also translates to monetary savings in the long run as well.
Yes, it converts. Yes.
Perfect. And then again, just for the benefit of the crowd and the audience, the solutions that you spoke about, are there any sort of subscription models that are available for them?
That we need to identify potential projects for that. If there are high savings in the project, we can opt for subscription models. Otherwise, it would be CapEx.
Understood. Let me just quickly check the chat box.
Yeah, so Mr. Ajay, while Huren and like our participants might have some questions. Okay. So we're just wondering, can multiple compressors be connected to a single compressor while we recover the heat?
I wouldn't recommend to do that because each and every oil in the air compressor has multiple different lives. So your mixing might cause more harm to the system. So usually we recommend to go for one heat recovery system per air compressor for being on the safer side. Yeah.
Perfect. We do have a question from the audience. I'm just going to read it out to you, Mr. Ajay. How much heat energy requirement for an automobile manufacturing unit can be met through heat pumps or heat recovery systems?
So it actually depends on what we are going to replace over there and amount of heat which is available over there. For example, as I said, if there is a 100 kilowatt air compressor system over there, we can get about 65 kilowatt per hour. So if there are like 10 such systems, so 65 into 10, we get 650 kilowatts from air compressors only. And similarly for heat pumps also, the current capacity, for high temperature heat pump, what we are talking about, it consumes about 130 kilowatt of electrical energy, but gives heat capacity about 270 kilowatts, like almost 3 times the capacity it gives. So again, it depends on what we are trying to offset and how much of heat is actually required. So in terms of heat pump, it is like you can connect how many ever heat pumps you want, but again, you have to look at the electricity cost and is it really, and also ROI is also an important factor.